Hey everyone, today we're doing expected value. And expected value can be calculated as simply the sum of a whole bunch of products. And the products are the probability of an event happening and the value of that event. So that's what these notations are here. And you can sum that up over all possible events. So if you have 10 different events, each one has maybe a different probability of happening, and each one has a different value. Then you simply sum up all of those products. So let's just jump right into a really simple example. A really simple example would be like a die. So I have a dice right here. It has 6 sides. Each side has a different number on it. So oftentimes you'll use these numbers as the value. So the question here is, on average, what's the expected value of a single die roll? And what we can do is we can simply take each value. So this side has a value of 1, this side has a value of 3, this side has a value of 6, and we multiply that by the probability of getting that die roll. So in this case, since this is a nice even fair die and it's 6-sided, the probability of each side is 1/6. So we can say there's a 1/6 chance we roll a 1, there's a 1/6 chance we roll a 2, 1/6 chance we roll a 3, 4, 5, and 6, etc. So when you sum up all of those, what is 1/6 of 1? Well, it's a 6. What is 1/6 of 2? That's 2/6. We add them all up. We should get, what is that? 21, 5, 10, 3, 6, 10, 15. Yeah, 21 sixths. Or about 3.5. Yeah, 21 sixths is 3.5. Okay, good. Just double checking that. Let's do a harder example. Let's do I got a D20 this time. So it has 20 sides. It goes up 1 through 20. And let's say I'm playing a game where I'm adding this example in. This isn't part of the worksheet. Say I'm playing a game where if I roll a 20, that's really good. I get $100. So a 20 leads me to getting $100. That's pretty cool. But on any other roll, I have to pay somebody else $1. So let's say I have 1 through 19 means I lose $1. So I'm going to put negative $1. Would you play this game? Well, to do that, we have to figure out the expected value of this game. We want to see whether or not it's a good idea to play the game just monetarily with our probability, or whether it's a poor idea to play this game. And all we have to do there is just realize that, okay, well, what is the odds of getting a 20? Well, it's 1 in 20, right? So 1/20th of the time, we get $100. So 1/20th times 100, and we're going to take that and we're going to add it to the probability that we don't get a 20. So how often do we get 1 through 19? Well, it's 19 out of 20. And then we're going to multiply that by the value of that outcome. So in that case, it's negative 1. And we're just going to add up these two things. So what is 1/20th of 100?
You said I didn't have to do math.
We'll say 100 divided by 20 is 5, right? And then we're going to add that to what is 19/20ths of negative 1. That's negative 19/20ths. If we want to put that as a decimal, a 20th is 0.05. So it's negative point 9 5. So what is 5 plus a negative 0.95? Well, that's 4.05. So that means on average, you'd expect as you play this game that per roll you'd earn $4 per roll. That's a pretty good deal. You could do the same calculation if they change the rules on you and they're like, okay, now it costs $5 each roll, or now you only win $20, right? Is it still worth it? You can do these calculations and figure out if it's still worth it. Obviously, there's other things that should impact whether or not you play a game like this, right? So if some random stranger on a street walks up to you and offers you this deal, there's probably a catch. There's probably a rigged dice or something like that. If somebody's trying to scam you. There's also things like risk versus reward. Can you afford to lose this game, 20 times in a row before you start getting your payout? If you only have, a little bit of money, is it worth it? Is it worth it to do it? If you have a ton of money, is it not worth your time? All these sorts of things can factor into whether or not you take a bet like this. But this is exactly the sort of calculation they'll do when they're doing high-level finances. They'll try and rate the risk of losing all your money on this investment versus the return. Let's do another quick example. This one involves let's say you have a salary of $2,000 every month. You have $0 in your account at the beginning of the year. How much money do you expect to have at the beginning of next year, or in 12 months, if you earn $2,000 every month? Well, that calculation's pretty easy. It's $24,000. So you're earning $24,000 a year, exactly $2,000 every month. Now we're going to add in a little bit of probabilistic stuff. So on top of that money, you also earn a bonus. However, the bonus has just this random chance thrown in. We're going to assume here that it's completely up random and it's fair random. It's not boss choosing you because I don't know, because you're the tallest one in the office or whatever. So we're going to say that there's a 60% chance that you get a $1,000 bonus every month. There's a 30% chance you get a $500 bonus, and a 10% chance you get no bonus at all. So now we want to ask, okay, by the end of the year, how much money do I expect to have? Well, it's $2,400 plus whatever your bonuses are, right? So you have to figure out how much those bonuses are. And we can do that exact same calculation. We take the value of each bonus and we multiply it by the probability of getting that bonus. So in the case of the $1,000 bonus, it's 1,000 times 0.6, right, or 60%. The $500 bonus, we're going to multiply by 0.3. And then the $0 bonus, we're going to multiply by 0.1. If you crunch the numbers there, that means we have 600 plus 150 plus 0. 600 plus 150 plus 0 is 750. So you'd expect every month, on average, you'd get about $750 in bonuses, right? Sometimes you might have 3 months in a row where you get 0, right? You might have 3 months in a row where you each get 1,000, but overall, you'd expect, assuming your probabilities are correct, that you'd have $750. If you played this an infinite number of times, or did this an infinite number of times, right? You get $750 per month in addition as a bonus. So that means each month, $750 times 12, therefore, is $9,000. So you'd expect by the end of the year to have $9,000 additional money in your bank. So your grand total should be about $33,000. So just another example. As you jump into these problems, again, try and find the probability of all the events, and then simply multiply those probabilities by what value they return. And then we add all those up. That'll give us our expected value. I will make another video showing all the answers to these problems. Good luck.